In our last lecture, we talked about the properties of water, and I went over the fact that water is a very special molecule. And one of the things that makes it so special is the fact that it's so polar, right? And what does that mean? I've said it many times, but what it means is that even though it's not water itself doesn't have a charge. It's not an ion, but it has an imbalance of its electrons. So there's more electrons on one side of the molecule than the other. So the oxygen side has more negative because it's got more electrons closer to it, so it's going to be more negative. And the hydrogen side is going to have less electrons, so it's going to be more positive. And what you end up with is this little tiny magnet. And what that does is it gives water the ability to do several things. One thing water can do is it can attract to itself, right? We talked about cohesion, meaning water attracts to other water molecules. The oxygen part of one water molecule is going to attract to the hydrogen part of another water molecule. And we talked about adhesion, which is how water attracts to other things. And I used the example of a meniscus in a graduated cylinder. If you've ever read a graduated cylinder, you know it kind of dips down in the middle. That's called a meniscus. And then we talked about the fact that water has a high heat capacity, and that's because of the hydrogen bonds. These water molecules form these hydrogen bonds. When the hydrogen of one water molecule attracts to the oxygen of another, that's called a hydrogen bond, and they actually can hold a lot of heat because that is where energy is stored. And then we finished up with this idea of evaporative cooling, which basically means that as water evaporates, it pulls heat from the environment. It's what keeps the earth cool, but it's also what keeps our bodies cool. So when you sweat, what's happening is the water pulls up on your skin and then it evaporates off. And when it evaporates, it pulls the heat from your skin and it cools you down. The last thing that we're going to talk about with the property of water is going to be the fact that it is a versatile solvent. So we're going to talk about that a little bit. What is a solvent? So a solvent just means that it dissolves things, and we're going to talk about that. But because water is so polar, because water attracts to things so easily, it's going to be a really good solvent. So we're going to call it the universal solvent. Anytime water gets added to anything and forms a solution, it's going to be the solvent. So let's talk a little bit about what a solvent and a solution is. Solvent, solute, and a solution. But the last thing that makes water, the last property of water that makes it special is that it is a really good solvent. So let's talk a little bit more about that. What is a solution? All a solution is a combination of substances that forms a uniform substance, essentially, a uniform solution. So it's always going to have two parts to it, something called a solute and something called a solvent. So let's just talk about those terms, and I'm going to give you an example. The solute is the substance that's being dissolved into the solution. And then the solvent is the substance that does the dissolving. So I'm going to use an example of iced tea and water. I like iced tea. It's delicious, right? Everybody likes iced tea. But nothing is worse than weak iced tea. It's like, ugh, I can't even drink this, right? And then if it's too sweet, you're like, oh, I can't drink that either. There's like this perfect recipe of solution, right? The water and the actual iced tea mix. So let's just go over a quick example of that and make sure we understand it. So let's say I want to make some iced tea. Take my glass. So I have my glass here. And then I'm going to have my water. I'm going to put my water into that glass. So we got our water molecules. This will be a whole bunch of water in here. Now water, in this case, is going to be the solvent. That's a V, not a U. Solvent, right? So the water is doing the dissolving. And then we're going to put our iced tea mix in there. So in this case, our iced tea mix is going to be purple. So we're going to put our iced tea mix in there. And if you get the perfect combination, and that thing is delicious, you're going to have a scenario where that's a really good mix, right? That's a perfect solution. So the iced tea mix, right? Iced tea mix is going to be the solute. The solute goes into the solvent, and then the solvent dissolves it. Solute plus solvent equals solution. Okay, so a solution is just made up of a solute and a solvent. And trick question, or the answer to this question, I should say, always is going to be, which is going to be water? What is water going to be in this scenario? Water is always going to be the solvent. It's the universal solvent. Universal, which means always, right? Universal means it always happens. Solvent. So that's one of the things that makes water special, is that it's such a versatile solvent. It's really good at dissolving things. And in the case here, we're talking about the fact that a solution is made up of two parts: the solute, which is the thing that's being dissolved, and the solvent, which is the thing that's doing the dissolving. We're going to finish up here with one last concept, which is called pH. Oh, sorry. Water is always the solvent, and that's an important fact. Water is always going to be the solvent. Okay, pH. You've all heard of pH before. You've probably seen commercials before where they talk about pH. If you have a swimming pool at home or a fish tank or a hot tub, you probably check the pH. So what the heck is pH? Well, pH very simply refers to hydrogen ions and hydroxide ions in a solution. What? That's confusing. So let's take a second here. If I were to ask you to tell me what makes up water, right? What's the chemical formula for water? You would tell me, hopefully, H2O. And one thing we know is when you have water, and we'll talk about this, water is neutral. Water has a neutral pH, and we're going to talk more about this. But I can also break that water into two parts. I can break it into something called a hydrogen ion, and I can break it into a hydroxide ion. So we have hydrogen, and we have hydroxide. Now, if I put these back together again, if I take hydrogen and, oh wait, so it's two H's and an O, right? H2O, 1, 1, 2, 3. So that's all I'm doing here, right? I'm breaking it into two. So the difference between an acid and a base, and we're going to talk about this in a second, it's a scale that goes from 0 to 14, with 7 being neutral. And what that means, essentially, everything that's going to be down this end, anything that's got more hydrogen in it, more hydrogen ions, is going to be an acid. And anything that has more hydroxide ions in it is going to be a base. So let's take a look at the notes that go along with it. So what is pH? Well, basically it just refers to the hydrogen ion concentration versus the hydroxide ion. So we just looked at that little scale, that little, I should say, diagram where I broke down water. We'll talk about that more. But it's a scale that ranges from 0 to 14. And an acid is any substance that has more hydrogen ions and has a pH below 7. And a base is going to have any substance that has more hydroxide ions and it has a pH above 7. Neutral is going to be 7. So I just showed you that scale, but basically if something's an acid, that means it has more hydrogen in it. And if something's a base, it has more hydroxide. And it's going to have a pH above 7 or a pH below 7. And so, for example, sodium hydroxide is an example of a very strong base, and hydrochloric acid is an example of a very strong acid. So let's just talk about some common household things that you guys are probably already familiar with, right? So some examples. Water, pure water, is going to have a pH of 7. Pure water is going to have a neutral pH. And what that means is it's going to have the same number of hydrogen and hydroxide. And I'm going to go back to that diagram to make sure we understand that. Now, hair remover, I don't know if you guys even know what that is. That's something that you might see commercials for it. It's this stuff that you put on that dissolves your hair. It's called Nair. But that is something that has a very, very high pH, a pH of 13. And that is going to be a very strong base. Soda, on the other hand, like Coca-Cola, really not that great for you to drink. That is extremely acidic. That has a pH of around a 3. So the scale is all over the place. So, for example, vinegar and lemons, tomatoes, those are all very acidic. And things like soap and bleach are going to be very basic. So I'm going to go back to that diagram again just to make sure we understand that. So we have water here. So water, pure water with nothing added to it, is neutral. It has a pH of 7 because the numbers of hydrogen ions and hydroxide ions are going to be equal, right? Because they're together. Now if I split that water molecule up, I get two options. Hydroxide over here, so we have our hydroxide over here, and our hydrogen over here. If I have more hydrogen than hydroxide, it's going to be an acid, and it's going to have a number closer to 0. And if I have more hydroxide than hydrogen, it's going to be closer to 14, and it's going to be a base. The more hydroxide, the more basic it is. The more hydrogen, the more acidic it is. And that is pH.